This video is part of the organization of markets. In it, I will discuss oligopoly. Oligopoly is a market structure in which there is a small group of firms. Strategic behavior is what sets this market apart. To better understand oligopolies, let's see how they compare to other market structures. First, consider the ability to set price, or market power. In every market except for perfect competition, firms are price setters. Price setters means they have market power or the ability to price above marginal cost. Again, only in perfect competition does price equal marginal cost. So oligopolists, like monopolist and monopolistically competitive firms, are price setters with market power, and so we see a price that's high relative to a perfectly competitive market. In both perfect competition and monopolistic competition, there is free entry. In oligopolies, however, entry has to be limited. There is some entry because, unlike a monopolist, there's more than one firm, but there are only a few firms or only a few dominant firms, and so entry is limited. Whenever there is free entry or exit, in the long run, profits can't be positive. That's because the entry would cause any existing profit to go to zero. Because in oligopolies, like monopolies, entry is at least limited, profit can be positive in an oligopoly market in the long run. Strategic behavior is what makes oligopolists different than monopolists, but we also see strategic behavior in a monopolistically competitive market, though to a lesser degree. Finally, in perfect competition, each firm is producing a homogeneous or undifferentiated product. In comparison, in oligopolies, like monopolistically competitive markets, products might be differentiated. So, in summary, oligopolies are similar to monopolies in that they are price setters, pricing above marginal cost, with some barriers to entry, and the ability to make a long-run positive profit. On the other hand, oligopolies are similar to monopolistically competitive markets in that there's strategic behavior and potentially product differentiation. Now let's look at some economic models of oligopoly in which there are only two firms. We call these duopolies. For each of the models, let's assume that firms are identical in their costs as well as their product. How these models of duopoly that we're going to consider vary are in two different dimensions. First, what the firm actually chooses. Either they choose price or they choose quantity. And then second, the timing of the decisions. In some of these models, firms act sequentially, where one firm is the leader and the other the follower. And in other markets, the firms act simultaneously. They choose at the same time. The Stackelberg model, which we will look at, is a model in which firms choose quantity sequentially. The Bertrand and Cournot models are simultaneous models. In the Bertrand model, they choose price simultaneously, and in the Cournot model, they choose quantity simultaneously. We will also consider a cooperative game to see what it looks like when firms collude and act like a monopoly. In a collusion model, the oligopolistic firms coordinate by setting their prices and quantities according to what a monopolist or single firm would do. However, firms have an incentive to cheat on any cooperative agreement because by cheating they can make an even higher profit. That's why we see that collusion models lead to the prisoner's dilemma. Remember, the prisoner's dilemma is a category of games in which players have a dominant strategy to cheat. So, with collusion, firms have an incentive to break their agreement because by breaking their agreement, they can make an even higher profit. But if both have incentive to break the agreement, then what happens is they end up at an outcome that's actually worse for them than had they honored the original agreement. You'll see an example of this in the oligopoly example I posted on Sakai in the lesson notes. The Cournot model explains how oligopoly firms behave when they simultaneously choose how much they produce. This model uses the concept of a Nash equilibrium. That is, an equilibrium in which each firm chooses a profit-maximizing quantity given what the other firm's going to do. We'll see that each firm produces at the profit-maximizing quantity. But what's different here is that the price that each firm can charge depends on the quantity produced not just by that one firm, but by the other firm as well. Therefore, there's strategic interdependence. The Stackelberg model explains how oligopoly firms behave when decisions are sequential. That is, one firm's the leader and sets its output before its rival, and then the rival is the follower. We'll see that the leader ends up having an advantage because the leader knows how the follower will respond and so can take that information into account to its benefit. Now let's look at how we would go about solving for the equilibrium price and quantities in a Cournot versus Stackelberg model. In both models, firms are going to choose their own quantity in order to maximize their own profit, where profit is their total revenue minus their total cost. Here, the price is the demand curve and can be represented as A minus B times Q. This is just the general equation of a linear demand. Notice, importantly, that the price is determined by the total quantity produced. That is, Firm 1's profit does depend on Firm 2's quantity. That's the nature of the strategic interdependence. To maximize profit, we, like usual, take the derivative of the profit with respect to the quantity the firm can choose and set it to 0. In doing that math, we'll solve for Q1 and find that Q1 is a function of Q2. Firm 1's best output choice depends on Firm 2's output choice. This equation that relates Firm 1's profit maximizing quantity to Firm 2's quantity is called Firm 1's reaction function. Sometimes this is called a best response function. It tells us Firm 1's reaction or best response to any action or quantity that Firm 2 would choose. Like Firm 1, Firm 2 will choose its quantity to maximize its profit, where the price that it charges depends not just on its quantity, but the quantity of its rival as well. Again, we have strategic interdependence. To maximize Firm 2's profit, we can take the derivative of the profit equation with respect to Firm 2's quantity, set it to 0, and in doing so, solve for Firm 2's quantity. Here we won't get a number, but rather an equation that relates Firm 2's best profit maximizing quantity to the choice of output by Firm 1. This is Firm 2's reaction or best response function. To solve for the values of these quantities, we can plug one firm's reaction function into the other firm's reaction function and therefore solve for the quantities. In comparison, in the Stackelberg model, one of the firms is a leader and the other the follower. Let's consider Firm 1 to be the leader. Firm 1 wants to choose its quantity to maximize its profit, where its profit depends on the quantity produced by both firms. Here, what we're going to do, unlike the Cournot model, is plug Firm 2's reaction function, the reaction function from the Cournot model, into the profit equation for Firm 1. What this represents is Firm 1, the leader, knows how Firm 2 will respond to any choice it makes about its output. Unlike the Cournot model, Firm 1's going to take Firm 2's best response into account when making its own decision. Firm 1, the leader, will take firm 2, the follower's reaction function, into account when maximizing its profit. Setting the derivative of the profit with respect to the quantity that firm 1 will choose to 0 now gives us firm 1's quantity value. We can solve for firm 2's quantity value by plugging firm 1's quantity value into firm 2's reaction function. As you can see in the example of Cournot and Stackelberg posted on Sakai under the lesson notes, being a leader gives a firm an advantage. By choosing its quantity first, the leader can produce a larger quantity than it otherwise would have, like in a Cournot model, and in doing that, grab more profit. The follower has no choice but to produce less output than it otherwise would, because if it too tried to sell a big quantity, it would lower the market price, since the market price depends on both firms' quantities. So because the leader moves first and chooses a large quantity, the follower's best response, profit maximizing response, is to sell a lower quantity than it would otherwise have done, and in doing so earn less profit than it otherwise would do. Being a leader gives a firm an advantage. Being a follower puts a firm at a disadvantage. Finally, the Bertrand model explains how oligopoly firms behave when they choose what price to charge at the same time or simultaneously. Each firm has an incentive to undercut its rival's price, because the firm with the lowest price is going to attract all the customers. Remember, we're assuming the firms are selling an identical product. If each firm has an incentive to undercut the other firm's price, they're going to keep undercutting price until price can go no lower. The only stable price in this model, the equilibrium price, is the price that equals marginal cost. For any higher price, some firm's going to have an incentive to lower its price to get all the customers. And again, in equilibrium, price will equal marginal cost. We get the same outcome in a Bertrand model as we get in a perfectly competitive market.